last example, then we'll go into that little game I talked about. We've done examples where we're on the cliff firing projectile. We've been at sea level firing projectile. And now, as Nick alluded to earlier, we're going to go into trench warfare. Anyone history buff in here? I like history. World War I is known for what? Trench warfare. What is trench warfare?
Dig foxholes.
Not just foxholes. Foxholes is just kind of where you protect yourself. They were building trenches. Trenches that were easily 8, 10 feet deep, reinforced, because that's where they spent their time. All right? And they did everything from these trenches. They communicated, they fired mortars, which is what we're talking about here. And these trenches went for miles and miles and miles. If you went across France, parts of Germany, parts of Hungary, Poland, and so forth, the land is just scarred with all these different trenches. Now, say we're in one of those trenches, and we're firing a mortar at the enemy out here. Okay? But we also have our own people that we want to make sure we fire over so we don't hit them. Or else it kind of defeats the purpose, right? So, say we start off with this equation, just like we've been dealing with, the negative 32x squared over 60 squared. And remember, in this case, 60 is our what?
Velocity.
The velocity, exactly. The mortar velocity itself, plus x minus 10. We've always had a positive before. Why is this minus 10? Exactly, we're 10 feet below sea level. That's the realistic side of it. Mathematically speaking, we're putting an xy axis right here, where the origin is actually right here. We're 10 units, or in this case 10 feet, below the origin. Yes, you have to admit it. Electronics on this side, IT on this side. You guys are always competitive with each other, and a little competition is healthy.
What happens if you're in both programs?
Too many jokes, too little time. Well, then you can choose whatever one you want, Josh.
You can pick those.
All right. Here's the situation. I have marker all over. Here's the situation. We have our IT here. We have our, wait. Okay, you guys are electronics, you guys, okay. You have two groups here. Each group will have 3 tries. What you're trying to do is you're going to try to hit a bullseye. Let me give you the dimensions of the bullseye then. We have the inner, the inner radius is 1 foot. The radius to one ring out, look at my notes so I don't screw it up, is 5 feet. And the radius to the outer ring is 10 feet. All right. Now, you're going to be firing 20 feet from the outer ring. And I'll put up the ranges of what is bullseye, 1 ring out, 2 rings out. In fact, I'll do that now. Technically, to hit a bullseye, you have to be in from 35 to 37 feet. In other words, you already have 20 feet here. You have another 10, 20, and boom, you only have 2 feet inside of here. 1 ring goes from 30 to 35 feet here, or from 37 to 42 feet. And 2 rings out, 20 to 30 feet. So what you have to do, and I'll give you 3 attempts. I will select the first person, then that person will pass off to the second person, that person will pass off to a third person as far as actually doing the work. I will take the best of your 3. As far as point value, if you get in the bullseye, it's 10 points. Bonus. On top of everything. 1 ring. 5 points. Every person in the group.
Okay.
All right. And if you get within 2 rings, or basically within here, or if you're ever shooting over here, still worth 2 points. A lot of opportunity, however, you have to work for it. Yeah. You mean I just don't give it to you?
I didn't write down.
Say again?
No, yeah, that wasn't a bad idea. You can document it, man.
All right, so you are at 6 feet, and oh, you have to write out everything, right? Just tell me what number you're doing. 30.
Change the answer just by a little bit if they're right now. Just stop by.
Come on, you're on the clock, go.
Serious?
No, I'm sorry, yeah. Sorry. But yeah, you are on the
I
clock.
didn't even finish my calculations.
Less talking, more ready, you had them done.
I was right.
Yeah, you're right.
Yeah, good. I think you use the same number.
You passing it off?
Yeah.
So soon?
Yeah. Marking out.
I worked it out.
There's too many numbers involved.
All right, Mark, what are you trying, bud?
28.
28 it is, okay.
I think I'm coming up way short.
How's that apple?
These are really big numbers. Everyone's got all this.
There's an app for that.
15 squared.
Oh, did you? Shut your time code. What's that?
No, I'm not favorite.
It probably has you like.
I'm sorry, you used 28, Mark? Okay.
There's 2 rules on it. I got the one that's right on. Like, if you can't get just 25 away. I got it at 30.64.
If you put in that it's actually getting dead, you know that value. That's the dead center.
I'm not serious, but that's not.
Yeah, I was gonna worry about this.
I used the answer you gave me. Figured out
That's off? Forget it, took out a chance. Your choice, Jake.
You're almost close.
Use
What's
that
that?
somewhere.
Your choice. Pass it off to who you want to.
I had the choice to pass out, otherwise I would stop at like
Use that
.28
first
or
access.
2.88.
Well, the more you talk, the more time you're wasting to someone else.
You think you got it? Justin, I don't know.
That's assuming whoever told me
You guys it?
30
Alright, good.
feet. Whoever said that, assuming it's correct. Otherwise, they have to.
See, I'm still, what, 27?
Okay.
And I'm not
1 second, I'm double checking here.
And now just because I started out high and I messed up my calculations and then I went way over in like the 70s.
Yeah, but like, I figured I was gonna do the math, but I don't know, finish the math at the end. So you just fuck up.
You would be next.
No, I'm not saying I wanna be next. What distance did you get?
29.5, which is 27.
Yes, it is.
Yeah.
Excellent job. So basically, you guys got it in 2 shots. You don't want to pass it off, you don't have to, you can't get any more.
Yeah.
So you guys are done. Excellent.